Hi, my name is Eric Chu, and I'm an industrial engineering major at Cal Poly San Luis Obispo. My senior project is based on an evaluation designed for Supplier A. My presentation will cover Supplier A's background information and their current production scheduling problems. Then I will discuss the design alternatives I developed, the testing of the designs, results, impacts of the project. Finally, I will discuss the industrial engineering tools that led me to my conclusions and my final recommendations to Supplier A. Supplier A was opened with the vision to provide the best products to its customers. Supplier A's cycle time to manufacture products is very lengthy, and Supplier A also lacks a production schedule to accurately maintain WIP and inventory levels. Supplier A is being contracted by Company X that requires Supplier A to be efficient. Right now, Supplier A's production system is not lean enough to fulfill current and future business needs of Company X. The metric that I will be measuring Supplier A's performance is whether or not the deliveries to Company X are on time or not. For this project, I was a part of Company X's team to ultimately audit Supplier A's supply chain and evaluate them as a supplier. The issue that I noticed with Supplier A is with their production control system. When supply analysts push work out to the floor, the ERP system does not place a prioritization of work orders, so the shop floor would be working on orders due months ahead instead of work orders due right now. Suppliers A's goal is to have a minimum of 3 weeks of orders on the shop floor and a maximum of 5 weeks of orders at any given time, but the ERP system does not differentiate work order due dates. This leads to an influx of WIP in Supplier A's production system that leads to lengthy cycle times from shop floor confusion. This process flow map is the assembly process of Supplier A's different products. On the bottom right corner, there is a legend describing the symbols. The green boxes show the Kaizen bursts and areas of improvement I identified within Supplier A's process. The letters depict Supplier A's different products that go through the assembly process. I was able to develop two solutions for Supplier A. The first design alternative is the Oracle ERP job scheduling. I chose Oracle because Supplier A is familiar with Oracle and already utilizes it as their MRP system. All they would need to do is purchase and upgrade the job scheduling module available on Oracle's online store. I also conducted a line balancing analysis to improve the assembly process efficiency. I was able to do so by calculating the number of workstations required by taking the total work content time divided by the cycle time of each workstation. The results include adding 2 workstations for hand assembly and 3 workstations for the soldering station. Hand assembly is the workstation in which workers assemble the external components of the product. The soldering station is the workstation in which workers meticulously paste solder joints onto the circuit board, which is an extremely lengthy process and leads to bottlenecks. The second design alternative is an Excel spreadsheet that I develop. The spreadsheet has 3 main functions: the ability to enter in additional work orders with the necessary information, such as job number, due date, arrival date, and processing time. There is also a critical ratio calculator to display which each work order's critical ratio. Green means it is on time, yellow means it is currently on schedule, and red means that it is behind schedule and should alert the operator that the job needs to be placed on high priority and should be run through the assembly process immediately. There is also a first come first served calculator, earliest due date calculator, and shortest processing time calculator. Each of these are different job scheduling techniques that Supplier A could implement in releasing its work orders to the production floor. The calculator will go through all the work orders and rank them, so then the operator can decide which method to proceed with. I learned firsthand how difficult it is in the aerospace industry to obtain any relevant data. Due to propriety and confidentiality reasons, the only data I was given was the processing times of the different workstations. I had to use assumptions for the rest of the project, including cycle times, assume Company X was the only customer, and assumptions about the economic analysis. I tested the alternatives by using a pro model simulation of the assembly process. Although the Cal Poly curriculum teaches a different software. I used ProModel at a previous internship and prefer it because of its increased capability and user-friendly interface. The simulation runs a total of 100 work orders. I created 100 different entities that represented work orders and ran them through the production process. Each entity had a starting and ending date, and based on the respective job scheduling technique, that was the order in which they entered the production process. As a result, I created 5 different simulations. Simulations included first come, first serve, shortest processing time, earliest due date, critical ratio, which is my second design alternative, and critical ratio with line balancing, which is my first design alternative. The following is the results of the simulation. Since the problem statement refers to the issue of whether or not supplier A was completing custom orders on time, I wanted my simulations to refer back to this issue and reference on-time deliveries. The first come first served method represents the most similar to the current process of supplier A because there is currently no prioritization of work orders on the shop floor. As a result, first come first serve will run whatever is in front of them. The results are clear. If supplier A utilizes the critical ratio while adding the appropriate number of workstations to eliminate the production bottlenecks, then their on-time deliveries will increase substantially. Here is the economic impact of the two design alternatives. To start, I used the online resource Glassdoor to approximate employee wages. Secondly, I used the cost-benefit calculations for the two design alternatives. Supplier A is currently underperforming. That is why an improvement in how their work orders are processed will result in immediate payback period. Either alternative will result in immediate profit for supplier A. On developing my design and finalizing my final recommendation, I had to consider any impacts it might have. The biggest impact it will have is on the employees at supplier A. The employees will need to be trained on how to use the Excel workbook and the additional ERP job scheduling model. Another additional impact is the transition from a paper system with printed work orders to an electronic system. I use many industrial engineering tools to come to my final recommendation. I use simulation, production planning, economic analysis, and flowchart analysis skills to complete the project. This project was a good overview of all the skills that I learned here at my time at Cal Poly. My final recommendation for supplier A is to use the Excel workbook that I developed for 1 year to allocate time to necessary plan the construction and the layout of the additional workstations. The additional workstations that will be added are 3 hand assembly stations and 2 soldering stations. The soldering stations will require the implementation of machinery, which will take time. Moving forward, ultimately, I would like supplier A to transition to Oracle ERP so that their systems would align together. Currently, they receive work orders through ERP, the Oracle ERP, and releasing work through Oracle ERP would ultimately be the best solution for them.